number is, as a Mach number is a ratio of the velocity of the speed of sound to the velocity, is a ratio of velocity of the object to the velocity of the velocity of the object to the speed of sound, generally written as m is equal to v by c. So where v represents the speed of the object and c represents the speed of sound, generally it is equal to under root of gamma rt, under root of gamma rt, and v is the object traveling velocity in meters per second or feet per second. Another, what is sonic velocity? Now the question is, what is sonic velocity, what is subsonic velocity, and what it is supersonic velocity. Whenever we said that it is sonic velocity, so there Mach number, so that it is Mach number is exactly equivalent to 1, where the Mach number is exactly equivalent to the 1. So where the velocity of the object, is exactly equal to the speed of sound, is exactly equivalent to the speed of sound. Now talking about the Mach number regimes, we have subsonic regime, we have transonic regime, we have sonic regime, we have supersonic regime, and we have hypersonic regime. Now, what is subsonic range of the Mach number is? So the subsonic range of Mach number is, so that it is Mach number is less than 1, and whereas a sonic Mach number regime is where Mach number is exactly equivalent to 1, and range of transonic Mach number is lies in between 1.8 to the 0.8. So that it is in between the range of 0.8 Mach number to 1.8, and some of the authors will write 1.2 also. And whereas the supersonic Mach number is above Mach, that means Mach number is greater than 1. Whereas the hypersonic Mach number is greater than 3 or greater than 4. Whereas some authors are being considered greater than 4. That depends, because that is varying with respect to the speed of the sound of that particular surroundings we are considering. Accordingly, that need to be chosen actually. So that need to be considered based upon the p by rho, gamma into p by rho, or under root of dp by d rho. So that based upon that values, this range of Mach numbers would be varying. So generally, or generalized values we are discussing it here in this one. Now talking about the propagation of the sound waves. So when you are talking about the Mach number, when it is subsonic, from one point source, the continuous wave should be point source. And here it is in the audible range. This sound wave, where it is stationary, that it is in the subsonic fluid flow range, where it is audible, and all the time the source of sound would say, so that it is Mach number is, when the Mach number is greater than the subsonic Mach number, and less than the sonic Mach number, in that case, as we can notice it here in this one. So here in front region of this particular one, so here the waves are getting compressed compared to this one. So here the waves are getting expanded. So behind the body or behind the point source, the waves are getting expanded, and in front of the body the waves are getting compressed. Comparatively, the distance is getting decreased in front, and behind the distance is getting incremented. When your Mach number is greater than the subsonic speed and less than the sonic speeds, so that means in front the waves are getting compressed. As of sound is not stationary, the sound source is also varying continuously, and the waves in front of the body are getting compressed. Now let us see the next case, whereas in this case when we notice it, so the sound waves are traveling with respect to the body. And at the same time, the sound waves are traveling with respect to the body. At the same time, behind the body, the sound waves are getting enlarged, and in front of the body, there are no sound waves traveling. So that means if the person is standing here at this location, if the person is available, it is inaudible. So that means he cannot hear that sound. So the person can only see what is the wave which is traveling behind the body. So that means after body traversing only, the sound can be noticed. Whereas in this case, see, in front of the body the sound cannot be audible until and unless the body hits this particular person. Within that is behind the body, because in this case the sound wave is traveling with when it is greater than 1. See, in the case of greater, even not in front, they are not even in front of the body, but they are just behind the body. They are emanating out they are expanding out behind the body, and there is no sound noticed in front of the body. So that means as far as this Mach number is concerned, the speed of the sound is very high. Sorry, the wave of the Mach number is very high. So that means the speed of sound is very low. The wave is traveling completely behind the body only. The wave is traveling completely behind the body only. So this is what about the Mach number when they are moving at the subsonic, sonic, and supersonic speeds, how the waves are being traversing, how the waves are traversing. So that it is in front of the body, the stationary source, that is Mach number less than 1, and Mach number greater than subsonic and less than sonic, and when it is exactly sonic, and when it is greater than the sonic Mach number, how this particular sound waves are propagating from the body, how the sound waves are propagating from the body. So talking about this propagation of the sound waves, we see that when when you are talking about the zone of silence and the action, so there is a one strong line that has been drawn, and that is actually indicating the shock wave here. So the wave formed in front of the body, where the properties of the fluids are varying all of a sudden. So when the Mach number is greater than 1, or when the Mach number is greater than the subsonic speed, there the properties are changing continuously, and at Mach number equal to 1, there is a shock wave generated. And within this shock wave range, where the flow properties are measured in front and behind the body, the flow properties would be changed. So abrupt changes in the flow properties, or all of a sudden property changes will be happening, so that it is across the shock wave. So what exactly the shock wave is? Shock wave is a very thin region. Developed, or a wave which is very thin region, across which the fluid properties would be varying very all of a sudden. So that we'll be calling it as a shock. And in the next videos also we will see about the shock wave and the property variation along the shock wave. So that we'll be considering it as an isentropic fluid flows. Now, so this will be called as a Mach cone. And that how Mach cone is formed. So that is whatever the traversing waves are available, traversing wave circles are being traced by drawing a tangent to that one, so that we got it as a Mach cone. Let us see another way of this understanding. And so when there is a zone of action and zone of silence, then these two are being separated. So this is being called as a Mach wave or the shock wave. So this is a shock wave where it is standing in front of the body, and this is nothing but the wave or the fluid influenced in this particular one. So that we'll call it as a Mach. And when it is Mach number equal to 1, when it is greater than 1 Mach number, we can see that complete tangents when we have drawn it. So this has given us a Mach cone. Completely this has given a Mach cone, where on the horizontal axis we have a traveling velocity, whereas the traveling velocity with respect to the time, and this is a hypotenuse of this one is considered, so that it is here we are considered it as an so that the line which is linking to this particular, so any point or the tangency where perpendicular is being drawn at that point, where tangency the perpendicular is being drawn at the tangent point, so that is nothing but the distance on that one. So this completely gives the what is the shock wave angle or the Mach cone angle we have obtained. Now the next question comes, so what is the importance of this Mach wave or the shock wave? Why we are interested to predict this Mach wave, and what happens exactly if the shock wave occurs on the body? So as we all know, when there is a sudden flow properties changes on that aircraft or the moving body, then the body is not, or the body should be prepared to take that particular, condition. If it is not prepared to take that condition, because of that abrupt or sudden changes in the flow properties, the aircraft may go for structural damage. The aircraft may go for the completely change in the flow because of the flow properties. There may be some failures also which may lead to. So for that reason, we should be very clear about. So generally, when we are doing with respect to the aerodynamic consideration, we'll always make sure that our aircraft design, the aircraft should be designed within the Mach cone range. So when it is within the Mach Cone range, when the Mach number is greater than 1, it is supposed to travel. So we'll make sure that it is within the Mach Cone. If it is outside the Mach Cone, so that means here the Mach Cone would be influenced on that body, and that may completely damage it structurally, and here the wing may get broken. The wing will get broken. So in order to avoid that one, so what generally we'll do is we'll initially know what is the Mach number of that one. So what is the Mach cone or the Mach angle of that particular, and then accordingly we will be designing the wing shape, or the wing angles should be taken accordingly in order to avoid the disturbances which is being created. And at the same time, because of this transmission waves or the compressibility waves which are traversing behind the body, so that means in this region, so the next other aircraft will also get this influence of the fluid flow. So we should give either time to settle down this air which has been distributed from the air, or when the one aircraft is traveling in this range, so at that range the other aircrafts will not be allowed, in order to avoid the disturbance not to traverse onto that bodies. So this is what generally we will consider, and why the propagation of the sound waves is important. This is what the reason, and why Mach wave we have to, why do we need to determine the Mach wave, is for this reason we have to determine what is the Mach wave and what is the shock wave we are supposed to determine, and how it is traversing. We have made it clear from this. That generally people will be calling it as a shock wave, or the sonic wave is attached to the body. Shock wave or the sonic wave attached to the body. Here we can see, so what exactly this Mach cone is, or how the Mach cones would be generally, we can see it physically. So here in this image you can see, so what is the shock wave traversing on the body? The theta is nothing but the Mach angle. Now another question is, how do we write this Mach cone or the Mach cone angles? How do we write it? So when you are writing the speed of sound, A, so that it is velocity of the aircraft which is traversing in the forward direction. V is the velocity of the aircraft which is traversing in the forward direction. And this Mach cone is available only when your Mach number is greater than 1. When your Mach number is greater than 1. The Mach angle is defined as the angle available in between the Mach wave, that it is angle which is available in the Mach wave, and that is generally given as sin mu is equal to 1 by m. Sin mu is equal to 1 by m. So where Mach angle can be directly defined as it is speed of sound to the velocity of the object. Mach angle is generally speed of sound to the velocity of the object, or in terms of the sign you can take it as sin mu is equal to 1 by m. Sin mu is equal to 1 by m. So generally when we are defining the speed of sound, so this is what the Mach angle. Now why Mach angle is important, why we are defining this one? Because whenever the flow Mach number, and this is valid only when your Mach number is greater than 1, then only we can see that Mach angles are possible. So flow compressibility effects can only be seen when your Mach number is greater than 1. When your Mach number is greater than 1.